Now, this is a good question from time, speed, and distance, which many people would take a lot of time to solve in the exam. So let's see, first of all, the traditional equation that people would form, the problem with that, and then how we can make this question much, much easier. So here we have a man traveling by a motorboat down a river to his office and back. He's going to the office and coming back, so downstream and upstream. With the speed of the river unchanged, if he doubles the speed of the motorboat, total travel time gets reduced by 75%. The ratio of the original speed of the motorboat to the speed of the river is what? Now, we don't have any actual speed or actual distance or actual time. We just have one percentage comparison, reduction by 75%, and then speed of the motorboat is becoming double. So here we have to understand that we don't really have to take too many variables. But before that, if we take a look at the traditional method, what people would do is they would let the distance be equal to d. They would take a variable. They would let the speed of the boat be equal to b. And they would let the speed of the river be equal to r. So people would take three different variables because we don't have any actual values. And then they would start forming an equation that in the original situation, the distance of d that is being traveled downstream and upstream. So one time will be downstream, one will be upstream. Now downstream speed will be b plus r, upstream speed will be b minus r. Okay, so the time downstream plus the time upstream will give us the total time in the original situation. And if you look at the new situation we would have the same distance, but now speed of the boat is becoming double. So downstream it would be 2b plus r. Boat is double, river is unchanged. And upstream would be 2b minus r. So this would be the time in the new situation. Now in the new situation, the time is reducing by 75%. Not to 75%, by 75%. Which means it is reducing to 25%. If you decrease something by 75%, it becomes 25% of the original value. And 25% is 1/4. So we can say that the new time is 1/4 of the original time. Okay, so if we take 1/4 of this entire original total time, the new time will be equal to that. Now see here, one thing you can do very easily, you can take d common from the left hand side, d common from the right hand side, and you can cancel them off. So keeping that in mind, why did we even need to take d? We could have just taken it as 1, okay, because anyway these would have been cancelled off. And we could have thought that ultimately we don't have any actual value. We just need the ratio of the speed of the boat and the river. Distance will anyway be cancelled off, whether in the equation or in the ratio. Okay, so just start with 1, a very convenient value. Then, so anyway, that would not give us too much of an advantage. People in the equation would be able to cancel off anyway. But now, this is the part where people would start solving it technically. Here, to make it easier, what I would do is, I would take one of these variables to be again 1. Now, whether you take b, whether you take r, doesn't matter. So for example, I would take b as 1. See, we can't assume something for both b and r because we don't know the relationship between them. If we already knew the relationship, then what would be the point of the question? We'd be able to get the ratio directly. If I know the relationship between b and r, that means I know the ratio. Okay, but the question is asking for the ratio. So of course, we can't assume something for both of them. But we can assume for one of them. So for example, we can take b to be 1, replace all with 1 here. So here 2b will be 2 into 1, which is 2. Here again 2. So now we'll just be dealing with one variable. And see why this works is, basically we'll be finding that if the speed of the boat is 1, then what is the speed of the river as per the conditions given in the question? And that will capture whatever is the relationship between them. Like if we get river to be 2, then speed of boat and river will be 1:2, for example. If we get river to be 3, the ratio will be 1:3. So now let's just solve it. So here we are getting 1/4 of. Now we'll get 1 minus r plus 1 plus r. So 1 plus 1 is 2, r minus r will cancel off. And the denominator 1 plus r into 1 minus r will be 1 square minus r square. On the right hand side, 2 plus r and 2 minus r, 2 will give us 4, r minus r cancels off. And here 2 square minus r square. So if we simplify this, Here 2 and 4 will cancel off. We'll get 2 in the denominator. That will be multiplied with 4 here. So 2 into 4 will be 8. So 8 by 4 minus r square. And here we'll be getting 1 by 1 minus r square. Now just calculate this. Okay, so if I just create some space here, we'll get 4 minus r square is equal to 8 minus 8r square. So we'll get 7r square is equal to 4. So r will be square root of 4 by 7. Okay, r square is 4 by 7. Then we'll take the square root. So we'll get 2 by root 7. So now if we have to look at b and r, the ratio of b is to r. Okay, motorboat to the speed of the river. B we've assumed as 1 and r we've got as 2 by root 7. So multiplying with root 7, we will get root 7 is to 2 as the answer, which is there in the second option. So you can see this becomes quite easy if we just deal with one variable. Okay, and we still get whatever relationship we need to get between them. So now get some practice with this method using this replica question and share your answer in the comment section.